Thank you. As I was introduced, I'm Allan Thomson. One of the things that I also do, I'm full-time at Looking Glass, but I also co-chair STIX and TAXII version 2 interoperability subcommittee. And that committee, I'll actually share some details about what that objective is as part of the presentation. I also have some live demos of some open source tools using STIX and TAXII. And hopefully they actually work, given the internet and everybody else being on here. But let's dig in. So before we talk about STIX and TAXII, I wanted to ask a question of how many people in this room have actually either created or use STIX in their environment, regardless of version. So I saw about 3-4 hands. We're good now, thank you. Yeah. So that is one of the things that I'm here to help change. Because one of the things that this industry really needs is to work together and collaborate in a way that starts to provide a way to fight back against adversaries. It's way too easy for actors who are targeting companies to attack. The previous gentleman just said, it's easy to be on the red team. Well, the way that we need to start changing the dynamics in our industry is start to actually share information that's actionable. And I'm going to go through some of how you identify that, how you use it, so that you can start taking it back. But STIX is the schema of the information that we're going to be talking about. But it's not just one aspect of that I want to explain. There's multiple aspects of information that you need to exchange. One is the higher level intelligence objects, which threat analysts are very familiar with, but in terms of who is building a campaign against your organization or against an industry. Those are typically higher level intelligence objects, and I'll actually show you some of that in a minute. There's also a lot of lower level, what I would call data facts. They're not really intelligence. They're pieces of data, like an IP address, like a domain, like a file hash, that when out of context is sometimes not actionable. And the reason why that is because until you start to put it together with other facts and other pieces of information, it may not be relevant to your environment. It may not even indicate a malicious activity. Now, STIX actually allows you to build both that higher level object model, but also all of the facts that support those higher level constructs. And those things typically are called in STIX cyber observables. Now, another key part of STIX is actually the pattern grammar itself. One of the things that STIX is about is communicating information to people who can share information and act on it. The pattern grammar allows you to programize that, and I'll show you some examples of that. We're also going to cover TAXII, and I'll have a live demo of that. That is the application that allows you to exchange STIX, and then we'll talk about interoperability. Let me give you a quick brief overview of STIX and TAXII. So STIX and TAXII have been around for a long time, but they've really significantly changed over the many years. So they started out in 2012. It was the original version that was developed to create information sharing. It was an initial attempt at trying to do that. There was a lot of theory and some practice that went into it. However, over the years, it became obvious that many companies who are building products for intelligence sharing, STIX version 1 had a lot of problems in terms of scale, in terms of usability. So STIX 2, which is now part of the OASIS community, which is a public standards organization, is a completely new version. It's almost like night and day different from STIX version 1. And STIX 2 is the thing that I want to kind of talk about and show you specifics. So at a high level, STIX 2, the first thing that most people talk about is that it's JSON, not XML. That on the surface might seem like, well, duh. It's like, why would you ever choose XML nowadays for anything? However, there's multiple reasons why JSON was chosen. Not just in terms of like programmability and ease of using the data, but also in terms of scale, in terms of flexibility that JSON provides. Now, XML provides some of that, but the key point is that it's much more effective and capable. Another key thing that I want to point out is that it wasn't just a data format from XML to JSON. It was also the data model itself that was fundamentally broken with STIX1. So STIX1 tended to model things very hierarchical. Excuse me, I'll get this. Very hierarchical. And from a tradecraft perspective, from how analysts build intelligence and build their knowledge about what they're looking at, that model was not very conducive and effective way to model things. So what STIX2 did was completely change how you build intelligence to a much more graph-based data model. And I'm going to show you a lot of examples of that. But that fundamentally is much more accurate to how threat analysts and multiple teams work on intelligence. They tend to build up individual pieces of information and then they correlate it together over time. Not everything is constructed all at once. And so having a graph representing all the data and then be able to leverage that using standard ways is exactly what STIX2 did. Now, TAXII is also, the application that allows you to exchange STIX is a sister of STIX, the schema. TAXII is how we exchange it between systems in a standard way. And TAXII also went from XML to JSON. It embraced RESTful APIs, which is a fairly modern, well, it's not modern anymore. It's been around for a long time. But TAXII is really much more moving into this century of how you exchange data. And there's various aspects that I'll show in a minute. So I want to cover 4 areas. One is I'm going to talk about the STIX2 data model and how you model things. That's the second part of how you model real-world things like intelligence reports, like we were just talking earlier about certain types of attack behaviors. The reason why people try to use machine learning from the previous presenter is because individual indicators are not sufficient. What you're trying to do is understand behaviors. Well, STIX2 data model allows you to codify what behaviors are, and then I'll show you how important that is from a tradecraft, but also how to do it in an interoperable way. And then the third part, I'll actually show you how TAXII works, and then finally talk about interoperability. So, as I said, there are 4 key aspects of the data model in STIX2. The first is domain objects, which is if you are trying to understand how adversaries are potentially targeting you, so for example, campaigns, understanding which actors are out there, is a particular APT group, is an individual, is it unidentified that you know very little information about, but you want to be able to model that you know it's a entity that's targeting you. There's relationships. So the construct of being able to connect individual pieces of information together that builds a greater picture. Cyber observables, as I already said, and then pattern grammar. So STIX2 categorizes different types of intelligence objects. One of the first things is how do you model adversary behavior? So as I've said, campaign. So I have a green group that's targeting with a specific objective of potentially exploiting a particular organization, maybe a financial institution. How are they going about that? How do you represent that? And STIX2, what you do is you start with an individual object and then you connect all these individual objects together to represent the overall perspective of intelligence. And we're doing that because what we want to be able to do is eventually share it with other systems that are going to ingest it as a machine, not as a human being. Because today a lot of intelligence tradecraft tends to involve human beings that have to read a whole lot of things to then determine action or some other event out of that. And what we're trying to do with STIX is really move it more to a machine-readable format that allows more automation and therefore ultimately be more real-time, be more actionable without human beings in the loop. We're not getting rid of human beings, we're really making them more efficient. So Another adversarial object is intrusion set. So if you're in, if you're a threat analyst, these are terms that you probably are familiar with. But an intrusion set at a high level is really just aspects of behavior that are in common across multiple campaigns. So an example might be where an individual campaign is targeting a third party who has the target example is always used as a pure example, but it helps explain this. So I apologize for the example. But how target happened was targets somebody who had access to the target network had poor security. They were targeted and exploited, and then the adversary then used that access to then get into target. So a campaign of targeting that third party would be a single campaign. But if you wanted to represent the whole thing of what their ultimate objective was, which was getting to target, that could be represented as a set of campaigns over multiple weeks or days, getting to target. STIX2, one of the key things that we focused on is really how do you model threat actors. And it's not just about their names, which you may not even know. They may have personas, multiple personas. But what are their capabilities? What are their objectives? What are their motives? And all of this information is something that needs to be codified so you can share it with other organizations. So for example, if an actor is targeting a financial institution, that intelligence, if you're not a financial institution, allows you to immediately, well, I don't care about this actor because they're primarily motivated by trying to break into financial institutions. So that information is very easily used to then filter out some of the intelligence you may be getting, as an example. So, I apologize, this is a very detailed slide, but I wanted to highlight a couple of things. The list of properties that you see there at the top are actually the common attributes that all STIX objects in STIX 2.0 have. I want to call out two things that are important from using STIX 2 perspective. The first is common versioning. So how you version all objects in STIX is really important, because if you're going to operationalize threat intelligence, what you really need to care about is not just when something was created, but also if it's updated, and also when is something distributed or published downstream. And so STIX has really thought about not just what data do I need to represent from capturing intelligence data, but how do I then operationalize it in an environment and make sure that those data properties can be used for systems that you're connecting together. And so there's a lot of rules that are actually defined in STIX 2 about who's allowed to create something, who's allowed to modify something, what are the rules for when you must modify something versus when you delete, if you decide to delete something, what are the rules? And STIX actually, has focused on a lot of those key operational aspects. The other thing I want to highlight in this is this simple little property created by. So again, operationally, this might seem like, it's just a data property, I fill it in or I don't. Well, one of the key things as a practitioner and creating intelligence or consuming intelligence is really where does intelligence come from? Because a lot of information that you're going to act upon, typically what you're caring about is the confidence of that data and how reliable is the source of that information. And so STIX particularly has focused on representing things that are very common in the trade, where you want to represent not just the intelligence, but who is actually creating this intelligence. Because if you get a piece of intelligence that has no source data, then how reliable is it? I attended the keynote this morning where they were talking about, how people try to influence elections by, information there. Well, if you don't know where information's coming from, how reliable is it? Now, with STIX, too, one of the key things they focus on is, well, we want to be able to identify sources, because then we can start to attribute trust, and we can also start to, know that I got this piece of intelligence in STIX2. It came from, blah vendor or blah organization, and it was, always accurate. It was always actionable, and I never had any false positives from that organization. So, whereas if I get it from, say, an open source organization, where they produce a lot of data, but it may be noisy, it has some false positives, then how you treat the data from that organization versus a more reliable organization who's always fairly accurate, changes how you respond to intelligence. And these are some of the things that STIX2 have really focused on. So it's much more than just about a data model and a database schema. It's more how you use the data and operationalize it. So another key part, the previous gentleman where he was talking about artificial intelligence and machine learning, and I broke his rule where you're not allowed to say both things. But the key thing is that how you model behaviors is a fundamental aspect of intelligence, because technical indicators, the cyber observables, without context and without really understanding how they connect, is a fundamentally important thing that you need to understand. And so, STIX2 has multiple aspects of TTPs. This one is an attack pattern. So typically, spear phishing, which is a very common way of trying to exploit, somebody, may be targeted, may not be. So you want to be able to represent, hey, this campaign or this intrusion set, always starts with a spear phishing email, and here's the details of typically of the email, for example. Tools are also important. So a lot of legitimate tools exist for important reasons, but they're also used by actors to potentially do scanning. So Nmap is a common one where, if you see Nmap occurring, scanning your environment and you're not expecting it, that could be indicative of malicious or intent. There's obviously a lot more that has to go into that decision, but the key point here is you want to be able to model, they send spear phishing, or they then use this tool in this way. So the ability to model those types of things and represent TTPs is really important. Malware, I think probably everybody would guess that that's a really important thing, but STIX2 has substantially gone into the details of that. So to be able to represent individual malware instances, malware families, and there's a new object in STIX 2.1 which is just coming out in a month or so, which is malware analysis. So we're able to represent sandbox output from running it, say, in VirusTotal with, or your favorite vendor who supports sandboxing capabilities. There's a lot of different dynamic and static analysis that are available in the market. Some are open source, some are commercial. And what we wanted to be able to do in STIX 2.1 is really represent all of that information in a standard format so that it can be shared. So now vendors can actually start to share their static analysis of malware as part of this new object malware. So 2 tips. One of the things that malware has is this idea of kill chain, which was originally, I think it's a registered trademark of Lockheed Martin, but there's actually multiple different types of, that concept of phasing of attacks. And one of the key things that STIX2 wanted to represent was how do we model attack patterns to that set of phases. So is this tool or this attack pattern typically in this phase of an attack? And so we want to be able to represent that, and that's why there. The other thing that's really important, which the intelligence trade typically shares information not as a public broadcast, is typically classified, which if you come from a more traditional defense background, that has a very specific meaning. And that's what STIX2 has embraced, because intelligence, you want to be able to say, okay, this is TLP red, if you're familiar with TLP. Whereas if this piece of intelligence is more broadly disseminable, then it may be TLP white or green or something. So STIX2 has really embraced some fundamental things that were either not recognized at all or were really hard to do previously. So another key part, what do adversaries typically do? They typically exploit things, and so representing vulnerabilities and understanding how that relates to the intelligence is a key part. Course of action. So STIX2 is not just about sharing what information you know about how you're attacked, but also providing ability to communicate how to respond to the attack. And so course of action is an object that allows you to represent both machine as well as human contact. And in 2.1, it's gone through a substantial revision that allows you to start to connect to other standards that are out there for course of action, such as OpenC2 and Cocoa. So if you're interested in any of those, I encourage you to look at them. Identity is really, how you represent individuals, groups, organizations. Report, I'm going to go through a specific example in a second where I'm going to talk about how you map typically an intelligence report and map it into a machine-readable version of it in STIX2. But there is this construct in STIX2 to represent those things. A couple of tips. Course of action, as I mentioned, is new in 2.1. Connect to a CV database. So STIX2 is not assuming that all information is contained within the single place or the single database. There's a lot of very rich information that's either in ticket systems, lookup databases like the MVDB. So the key point is that STIX2 allows you to represent those things. So it doesn't require you to pull all this information in a single place. You can actually connect and relate your intelligence to these other sources using some of these constructs that are in STIX2. Indicators are typically much more lower level, but they tend to represent things that are of interest. I won't call malicious because there's many things that are of interest that may not be malicious. And so what you want to be able to do is represent what behaviors or data represent something of interest. And so STIX2 has introduced a pattern grammar that is very, very similar to like regex. It is regex, but it allows you to express, options where you can combine things like if you see this email address with this domain and this file characteristic, then this is an indicator that I want to fire in my environment for whatever reason. Observed data, it represents where you're actually starting to see things changing. So the previous presentation talked about, a solution where it would I understand endpoints or the data on endpoints. So things like registry modifications, file socket behaviors. And observed data in STIX2 is a way to represent all of those individual pieces of data in a collection. Now, in STIX 2.1, this is actually substantially changing to allow you much more flexibility. And it's a fairly advanced topic, but the reason why it's enhancing it is because organizations wanted to be able to represent those individual facts directly related to other data, and STIX 2 didn't allow that. A citing is a citing of you saw something in the environment, and you can say as little or as much as you want about that citing, and that typically is very useful for if you've got a community of intelligence organizations that are seeing all of this intelligence being posted, and they say, hey, I saw that indicator, or I saw this campaign, and you can say, literally, you can just put your hand up and say, yep, that's all I saw, and you don't provide any details. But STIX 2 allows you to actually provide a lot more details using the observed data and the citing construct, where you can say, I saw that thing, and here's the specific details of what I saw. STIX 2.1 has a whole lot of enhancements. Now, given most people in the room didn't, there was about 3 people, I think, that said that the word was STIX, but there's a lot of continuing development to improve things. I think I'll call out one specifically, which is around internationalization. So we live in a world that has many different languages, obviously, and we want to be able to represent the intelligence not in a single language. There's important reasons why that is, not just for locality, but also things that are expressed in one language in a certain way could mean something, and if you did a Google Translate to your language, it might not translate the meaning or the intent of what that thing said. And so intelligence is about interpretation and understanding, and so it's really important that you represent the original data as well as potentially having translated versions as well. And so STIX 2.1 introduces that capability. What else do I want to say? I think we'll keep going. So one other thing I mentioned was the confidence of the data. And STIX2 recognized that there are many different forms of how you represent the confidence of that data. So some people might be familiar with the Admiralty scale, which is one way of doing it, WEP, 0 to 10, high, low, medium. And STIX2 recognized that many vendors have legitimate reasons why they want to use different scales. However, if you're going to share intelligence and have a common way to represent or to understand these different schemes, then STIX2 actually came up with a model that allows you to normalize it into a common scheme across those different scales. So if you're used to using Admiralty scale, you can continue to do that, but you can then publish your data in STIX2, and somebody who uses 0 to 100, there's a standard mapping of how you represent Admiralty into 0 and 100. So want to move into giving you some high-level information about the data model. Want to start talking about how you actually start using it in practice with some reports. So I have two examples. One is an intelligence report that I'm going to go through and show you how to take a higher level intelligence report and map it to STIX2, and then I have some modeling around APT actors. But at a concept level, what people are trying to do when they model things is they take all those individual objects that I just described, but then you start to connect it in meaningful ways that you'll represent a construct that you want to act on. So if you would like to follow along, this report, it's free to download. I'm going to go through the example, and I'll just switch to the screenshot for a second. So this is a report. It's based on a LimeRat, which is a remote access tool. This report is a high-level report. You can see it's TLP green with A1 confidence. It has a high-level executive summary. It talks about when the information was initially observed, any attribution to the actor, in this case that name. It has some key points. Then goes through some more detail about LimeRat. It then goes into some screenshots taken from GitHub. Then talks about some of the information about malware, how it does its behavior, et cetera, et cetera. Then has some screenshots of the ransomware feature that it includes, and so on. So that's a high-level PDF report that is very common in the industry. This is, obviously, from Looking Glass, but there are many vendors who do this type of thing. And the key point here is not to really, say, okay, that's it. It's like, well, how do I operationalize this? How do I turn this into something that I can act on? Because if I get a PDF report, I can scrape the PDF for words, and maybe I can pull out indicators using that. But and people do that, by the way, that's a very common thing. But the key point is that if you really want to operationalize structured intelligence, you need to figure out, okay, how am I going to construct a data model that represents this whole report and all of the information that's in the report in STIX2 so that I can then communicate it in a machine-readable format. So if I go back to the PowerPoint, and as I say, this report is downloadable so you can follow along if you're interested. I want to show you an open source tool where what I did was to kind of help talk through the report. There's this open source tool called the STIX Visualizer. It was initially developed by some folks at MITRE who are funded by the DHS to help fund some of the development. And I want to show you what I did. So I will switch to this is the JSON. It's not switching. I don't know why it's not switching. Maybe I need to. I'm going to go out of slide mode to see if it. Okay. So this is the raw JSON that I constructed. As you can see, there's a lot of details in there. There's a whole lot of object pointers and stuff that a human being can read, but you really don't want to be constructing this yourself because this took me quite a while to do this. And obviously that's just one report. If I have 10,000 reports a day or 1 million reports a day, then human beings quickly are going to be exhausted. So this is the raw data. If I go to my browser, this is the STIX visualizer URL, and what you can do is it has different ways to load it. You can choose files. What I've done is I've pasted the content in here, and you hit parse. And I wasn't sure if the internet was going to be flaky or not, so I wanted to kind of preload it. So I have this tab set up where what I did was I parsed the JSON that I just showed you, and if I can zoom out just enough, you can see the STIX data model representing aspects of the report. So you can see, for example, the legend on the right-hand side, and then you have the main actor. It has a location. It has a couple of attack patterns, for example. Key attack patterns are over here. We have a marking definition. We have a couple of other actors who have actually commented or provided feedback. And what you're starting to see here is that graph data model in reality within the STIX2 data model. So I've created these individual constructs, and then I'm starting to connect them in a way that represents what the actual report is representing, but it's in a machine-readable format. Now, if I click on one of these, for example, down here, the tool, the open source tool, actually shows you the node, all the data like created, modified, all of the objects that are part. I clicked on the report object, so it's actually showing me the connection to all of those objects that are part of the report. And the key point here is that it's an easy way to quickly represent and view what is ultimately, typically a JSON report is not easy to read as a human being, and as analysts, this is what you really need to understand. You need to be focused on using the data rather than having to worry about data formats or trying to make sure that you've got object pointers connecting to object pointers. So this is starting to kind of up-level the use of the intelligence in a way that is more useful. So if I go back to my slides, apologize, didn't realize that slide mode didn't. So the first thing of the report I want to call out is intro stuff that was on that initial page, and it was the identity of who's publishing this information. So in this case, Looking Glass, but it could be anybody. It could be a government entity. It could be an open source organization. It could be a financial FSI, for example. What's the report? The information, and these are on the right-hand side here. You see specific STIX2 data model objects of what represents the coming out of the high-level report. So the first thing is TLP green. That gets mapped to a data marking in STIX2. The next part is the confidence level, which gets mapped to, in STIX2, confidence is actually a property, it's not an object, but the key point is the same, that it maps to something in STIX2. Intro paragraph, it's an executive summary, but really it's identifying one primary thing, which is the threat actor. In this case, I don't know how you say that, INXCAT. Then it starts to talk about things like, remote access, ransomware, key logging. These are all attack patterns that need to be represented in the data. And so these high-level sentences, if you're an analyst, you would have to read it and then figure out how to, okay, what does this mean to me in my environment? Well, STIX2, if this was all represented in STIX2 and you saw in the STIX visualizer, it's already easily more machine readable and therefore processing much more quickly and effectively. Malware, malware objects, indicators. So in this case, LimeRat communicates with Pastebin. And that's an indicator. There's also an indicator for, there's some code that's been shared about some plugin. That is also an indicator that you can use potentially. There's more details on some of the attack patterns. So for example, like the encrypted communications between the server and the client. What does it do in terms of like spreading? So it infects all files via USB. Indicator, so the payload is typically 25K, so that can be used as an indicator. So these things that are expressed in human language, doesn't have to be English, it could be Hindi or Hindu or Mandarin. The key point is that the more that you map it to a construct that a machine understands, the less you're dependent on human beings for a start, because we are all fallible and we all interpret things differently. And the more that you are able to map it to a common construct that can then a machine act on, that's one of the key objectives of STIX 2. So, you know, there's two other threat actors who've commented on the usefulness of LimeWrap, and so those are obviously information that you want to retain. Why? Because maybe they're actually using a variant of LimeWrap. Now, this individual report makes no mention of what those two threat actors are doing or what their objectives are. However, you may learn later, 6 months later, 12 months later, that those actors are actually targeting a different organization or a different, you know, using LimeWrap or a variant of it with some other capabilities, and they've combined it into a new way, and they are attacking your organization. So this individual report might just have a name, and you want to construct that, but maybe 6 months later you get additional data that graph data model that STIX 2 allows you to model, then allows you to attach that additional intelligence to that original report data and builds up a much greater picture of the world that you're trying to understand and act upon. You know, location is another key part. You know, sometimes it doesn't really matter because an adversary, you know, especially skilled ones, will deliberately try to obfuscate where they're really coming from. Because they might think that, you know, that somehow matters. But the key point is that, you know, an attack may be started from a country X, but the adversary was actually in country Y, and they were doing that to try and point the finger somewhere else and obfuscate it. You know, it could also be that they're attacking you from a Tor exit node. You know, and so, you know, Tor deliberately tries to obfuscate, even although it's, you know, somewhat trackable to a certain extent. So the key point here is that you want to represent, you know, these uncertain facts. So it's not just data facts about a specific IP, a domain, it's about behaviors and uncertainty. Because that is what intelligence analysts are really trying to represent, is that nothing is black and white. You know, I'm not a threat analyst, but I work in this field, and so trying to have a conversation with a threat analyst about certainty is very frustrating, because they feel that they're not able to say black and white, it's this. There's always degrees of certainty or uncertainty, and that's what STIX 2 is representing, is that uncertainty. And that's important if you're considering having a machine act on that information. Again, it's all about operationalizing the intelligence. So the next example I wanted to show you is around 3 APT actors, 28, 1, and 29. The reason why I put this information, which ultimately came from MITRE attack, so this is not looking at derived information. This is information that was, I think the previous gentleman talked about MITRE attack framework. I too am very, bullish about people learning that, because it's a really important, to understand behaviors, and the relationships between behaviors is really important. And this information comes from this. So 2 of the actors have been attributed, based in intelligence, to Russia. And APT1 has been, a different organization or a different country. And what I want to point out in what I'm going to do next is how you start to see common behaviors regardless of where they're coming from. Now, why does that matter? Well, if you're a defender, you're the blue team. What you're trying to do is, if you're an enterprise organization, you're not a government. If you're an enterprise, you're not law enforcement, so you're not going to go and go after somebody. What you're going to do is you're just trying to understand what are they doing, how are they doing it, and so I can figure out how to stop them. All right? And you don't really care about this, the threat actor from that perspective. Now, you might have attributable information that you can then pass on to a law enforcement organization if it is criminal, but the key point is that what you're really trying to do is understand behaviors. And one of the things that this information, which I say came from MITRE, what you can start to see when you start to represent all of these objects and connect the dots, you start to see common behaviors and common attack patterns. Now, once you start seeing these things, the more public this information becomes, the more likely, especially if they're sophisticated actors, the likely they're going to change. If you say actor X is doing this particular type of thing in the network, they send this specific spear phishing email with this content, and that's published on the internet, then guess what? They're not going to do that much longer if they're smart, because then it's easy as a defender to stop that. If they keep doing that, you say, yep, I saw that, just stopped it, right? So adversaries are not that dumb. It's also much easier for them to pivot than it actually is for a defender to pivot. And so the key point here is you start to build up a picture of the different attack patterns, the different TTPs, and that's really important. So let me switch to the tool I want to show you in the browser, and hopefully it switches. It didn't switch, so I'm going to go out of slide mode again. And then go to the browser. So I have a tool, but this could be any tip. Ultimately, this is a product that we've built. But the key point here is that we have a threat actor information that came from MITRE ATT&CK. This case is AP28. You see all the information that came from MITRE ATT&CK framework. So they have a whole lot of citations and information, some attributed to CrowdStrike, for example, some attributed to FireEye. And this is the threat actor. So if I go to the model and understand the relationship, you can start to see I have APT28. I then have some APT information about different types of behaviors. So they evade defense. One of the things that I wanted to point out is this behavior here, which is lateral movement. Lateral movement is using a technique or attack pattern called pass the hash. Now, if you didn't have, if I hadn't expanded this already, then you would see that APT28 does lateral movement and it uses, pass the hash. But by expanding it, I've actually now seen that, the two other actors are actually using pass the hash as well. And they're also using it for lateral movement. And who are they? Oh, that's APT29 and APT1. Now, that you might say, well, so what, right? Well, intelligence is about informing action and informing how you respond to that intelligence. And depending on your organization, you may decide to say, I don't know what to do with this. But you may also be a more sophisticated, entity, and you say, okay, well, let me go see how I detect lateral movement. What defensive tools and controls do I have in my environment for lateral movement detection? Do I have a gap in my security posture? If I do, this has just informed me the relevance of that to your environment. Do you have a vulnerability that pass the hash potentially exploits, or that technique exploits? You can start to use this intelligence to map it to your specific environment and your specific needs and understand your risk. Because ultimately, intelligence is about driving risk and understanding how to respond to that. And so hopefully you see the point of why this is really important. So if I go back to slide mode. So the second example is, what I just pointed out in the live demo, where, once you start to understand all these actors and you see these, behaviors, you can start to see commonality, and it allows you to inform how to respond to it. The more actors you see using a common technique, that might help prioritize how you respond to it as well. Another example where APT28 and APT1 are actually doing data exfil with compression. They may be using similar techniques in that regard, and again, it can inform how you respond. So, I want to move on from how you model things, showing you a couple of examples how you model real-world reports, but they're really examples, and I want to talk about TAXII v2. TAXII v2 is the application that allows you to exchange intelligence between systems. And version 2 is fundamentally different, really, than TAXII v1. The first thing is that the server advertises what is on TAXII 2. That construct is called APT routes. It's a list of where the information is on TAXII. An AP route can be set up for an individual sharing community. It could be different. You could have different routes for different sharing communities. So if you have a particular centralized server that's shared across, say government, enterprise or vertical markets, as well as specific paid intelligence versus free intelligence, you can use the same TAXII server and have all of those different flexibilities on the same server. So you don't need to set up separate servers. You can actually all do it in TAXII, and there's good reasons why TAXII tried to do that. One of the things that TAXII does is it has this construct of collection. It's really just where the raw information is, the intelligence is. You can do read-only, which means that you can't write to it. And why would you have that? That would typically be, say, in the United States, the DHS has a sharing program called AIS, and that is where they publish intelligence information to a broad set of vendors and organizations. It's a read-only source of information that's not write in that particular instance, and so that would be a case where you would have an entity such as DHS who has a read-only collection that's publishing the intelligence. A write-only collection is curiously, some people might say, well, why would you have a write-only where you can't read it? Well, this came about because of organizations like IBM Security, who's involved in a lot of this too. Is like they wanted to be able to have systems that would post information to a TAXII server, but those systems were posting it, as an input queue. So it's being treated as, here's information that then goes into a processing data queue that then gets processed and munged and correlated, but that queue is never read from. It's only read from that server after it's been processed and published in a different place. And so they wanted the ability to have systems publish the information in a read-only way so that they can then be post-processed. And then there's obviously read-write. There's some constructs that are really important from TAXII. Filtering is super critical, because if you've got millions of indicators or millions of individual pieces of intelligence, your system might not be able to handle that much data, and you need to be able to reduce the data set that you're trying to get. You might not even care about different types of data, so you only care about, say, technical indicators, or you only care about high-level campaigns. So there is a way in TAXII to actually filter that information so that you can only ask for that type of information from that collection. Paging is another thing that, if you've built any kind of scalable application where you're communicating across, a network, you can't assume that you're going to get all of the information you're asking for in a single request response, even if it's a higher level protocol. So TAXII supports the ability to page information, so you can say, I want all the information you have from this certain date, but I can only handle 1,000 at a time. And TAXII allows you to actually do that, and it's on a per client basis. So, one client could say, I can handle 1,000 things at a time, whereas a second client could say, I want 10,000 things at a time. And TAXII allows you to be able to do that. This is some of the API that you would actually see. I want to talk through more details, but this is all the raw RESTful APIs, if you will. So, simple example, if I want to discover a server, the left-hand side is the client connecting to the server, and you see the response on the right-hand side there, and I highlighted the information that I was just talking about with routes. So, in this case, there's 3 routes, AP1, API02, and Trust Group 1. So, there's 3 routes on this server. The next one is, okay, I'm interested in AP1. What information is available here? So I wanted to highlight something that's really important, which is when you connect to servers and clients to servers, version control or version matching is really important, otherwise things just break. So the ability for clients to determine what is on a server and vice versa is really important for compatibility, and STIX TAXII allows that as part of the basic negotiation that occurs at the beginning of the communication. You also see a parameter there called max content length. That tells the client what is the maximum content that the server is willing to support in either a GET or a POST. So once you've discovered the list of API routes, you got a specific API. Now you want to go to a specific collection, which is where the information may be. There's a couple of things I wanted to point out. Permissions, which I already talked about. It can be per collection for all clients of that collection, or you can actually say for that individual client only has read access, it can't write, but you can, for this client, it can be both read and write. That is actually supported in a generic way in the standard, but it comes down to the implementation of the TAXII server, whether they support that or not. This is another key thing where you're able to do object retrieval based on filtering, which I already talked about. I'll skip this for a second. Posting information to TAXII is really important, and how well the data was posted is really important. So if you're posting, say, 10,000 things, 10,000 indicators, 10,000 intrusion sets, whatever it may be, you want to know, did that TAXII server actually process those 10,000 things correctly? So TAXII has in the protocol an ability to say, how many did I receive? So it confirms that, you know, if I know I sent 10,000, did it think I got 10,000 or it got 10,000? So it can say that. And then how many were processed? So that's important because if I've got some incorrectly formatted information, the server can actually communicate back to the client saying, hey, this information, I got 10,000 of them, but one of them or 5 of them were actually not processed correctly and they failed. Now, the protocol actually allows the server to communicate what were the failures, not just the number, because if it was 10,000 things and it said 5 failed, the next question the client's going to want to know is, well, of that number, what ones are failed? So there's some very real practical products that matter. So I want to show you a demo. So Jupyter Notebook is a open source tool. I'm going to run it against TAXII server. And you know, I wanted to show you, I'll go to screen mode and go to my browser again. And so here, this is a Python script you can see here. This is the Jupyter Notebook. I wrote this script with, you know, I took some of the scripts from a colleague I work in the standards, Trey Darley. He wrote the original version and I kind of modified it for this trade show. So thanks to Trey. But the key point here is that you might look, oh, this just looks like code, right? Well, what you can actually do is you hit run. The initial thing is I connect to the server. I set up this server object. I'm connecting to ubertaxi.com. That is actually in the internet. If you had a taxi client, you'd be able to go there right now. The password is ubertaxi, and the password is there. If I go to the next step, I say, okay, what is the title? And luckily, the internet continues to work. So this is the title that you know, is actually on that server right now, and it was retrieved. I go to the next step, and I say, okay, show me what API routes are on this TAXII server. And so this code is actually getting that data back, as I showed you on the slides. You know, get it API routes, and now it's printing out each of the TAXII routes that are on that server. And then I get to the next step. I hit run, and I'm specifically for this demo interested in the MITRE ATT&CK collection that's on that server. And so I find out which one that is. And then I go to the next step and set up a collection in the Jupyter Notebook. I then say, okay, how many results are in that collection? There's 60 from MITRE, small number, but for this demo it's good. I'm specifically interested in 36, which is MOA-FI. I then want to iterate through the relationships, and hopefully it comes back. Didn't look up. Oh, there you go. Find 2 relationships, and then I run the last step. And so that collection has MOA-FI, and it has 2 relationships that have binary padding and Powys and Ivy. And that was actually this client open source client in Jupyter Notebook. I encourage you to get familiar with it because it's a really useful tool to kind of learn how to use STIX and TAXII version 2. And it was talking to, in this case, the Uber TAXII server. There's multiple public servers on the internet that the community have been posting so that people can learn how to use TAXII 2. So if you have questions about either this one or others, let me know. I think I've got about 5 minutes left. I just want to quickly mention STIX Preferred. So one of the challenges with STIX version 1 was that it was easy for any vendor or organization to say they supported STIX. That it was literally that. They would say, yep, I support STIX, and people would believe them. However, when you come to do things like connect products together, like a tip talking to an endpoint system that claims STIX1, then they wouldn't work. And the people who were frustrated with that were joint customers or people who are trying to use products from different organizations. And so STIX2 has focused and created a new certification program called STIX Preferred, where organizations can submit their products for certification, and once they pass, they get a badge that says they are STIX Preferred certified, and it actually lists different personas. So this is the URL where the portal is. You can see who's actually got the certification. So far there's none because we just launched it. But the key point is organizations can submit their products, and if you're a consumer who's interested in what products out there are STIX Preferred, then you'll be able to go to this portal and it'll actually list the products. There's a whole lot of testing and test documents that are defined. If you're interested in the details, I encourage you to look at that. We've understood the market in terms of personas, so it's not just tips, it's also things like data feed providers, SIMs, taxi servers, threat mitigation system, detection systems, intelligence sinks. All of these personas are common things that are in the industry, things like firewalls, IPSs. So we've modeled how STIX would be represented in each of these product categories, and then we've defined for that product category what are the requirements on how it either produces or consumes STIX or both. And so if they get the certification for STIX Preferred for that persona, then you, if you're a consuming organization, you know that that product has met a certain level of quality way before, in STIX1, they used to say, oh, STIX V1, yeah, I'm compatible, and it meant absolutely nothing. We're changing the bar here to make it much harder to say you're compatible. I'll skip over that. We've focused on data, behaviors, and completeness, so it's not just specific elements of testing. We actually expect the whole thing to be testing behaviors and data. And with that, I will try and wrap up. So here's some links for information around OASIS, which is the standards organization that is pushing STIX and TAXII. The subcommittee that I was just talking about with STIX Preferred, that's the one I co-chair, is there. If you are interested in the specifications, either the STIX, TAXII, or STIX Preferred specifications, that's the link there. And there's also a list of open APIs and repos. Some of the tools that I just showed you are referenced there. And with that, I will thank you for your time. And I don't know if I have time for questions. Any questions? Time? I know it's long. Oh, I have a question. Be quick, because everybody's dying to eat.
Sure. STIX objects that you referenced earlier, they can be ingested or pushed out, right?
Yes.
Platforms tend to support a lot more ingestion than they do in terms of pushing. They don't push out all objects, but they happily ingest most of them. So is that something you see fixing itself in the industry over a longer time period, or is that something that with your certification programs you see adhering to in the near future?
So if I think I understand your question, what you're saying is that some systems are able to consume way more types of data than produce data. So STIX, to implement STIX2, you don't have to support all of the flexibility or all the different types of things that STIX2 does. If you're a firewall and you only care about one specific type of technical indicator, that's all you need to support, and STIX Preferred actually assumes that. If you want to get STIX Preferred certification for a firewall, you only need to support the things that make sense for a firewall. You don't have to support things like a higher level campaign or intrusion set, which a firewall would like. What the hell does that mean? Whereas if you're a tip, then typically tips must represent all of the different types of intelligence because they typically allow you to create all of that as well as consume it. So that is very much part of STIX 2, the assumption that you don't have to support everything in one place.
All right, thanks.
Okay. Any other questions? If you're interested in discussing more, you don't want to ask it in this forum, I'm here this afternoon. We have a booth. I'll be by the booth. My goal with presenting here is to actually encourage the industry to adopt standards. I fundamentally believe that that's how we actually start taking the fight back to actors who they're able to succeed. And I think we need to start using something, some standards like this that really help us work together to actually get back at the actors who are trying to exploit us. So I encourage you to embrace standards and ask questions. Thank you very much.